All right, so we didn't get to talk through division before we went on our break, so I would like to kind of summarize this last section in chapter 6 here, talking about division of fractions. Okay, so a first nice step for understanding division is by talking about division of two numbers with a common denominator. And in that case, division of fractions can be viewed as an extension of division of whole numbers. So we can kind of understand division in the same way we understood division of whole numbers. So if I look at an example of, say, 6/7 divided by 2/7, what I'm asking is how many groups of size 2/7 can I fit into 6/7? Okay, so I have this strip. I think I've divided it into sevenths. We can double check. 1, 2, 3, 4, 5, 6, 7. They're not exactly equal, but we'll pretend that they are. And what I want to do is I want to divide this. I want to see how many sets of 2/7 I can divide. Here is 6/7, right? Is just this strip. And I want to ask myself, how many times can I take that 6/7 and divide it into 2/7? And that's 3. So 6/7 divided by 2/7 is equal to 3. Okay, so if I take division of fractions and I have the same denominator, what I notice is I can, in this case, if I take A divided by B and C divided by B, so I have this same denominator here, I can really just ignore the denominators and I get A over C. And that's exactly what happened in our example. I had 2/7 and I divided by, or sorry, I had 6/7 and I divided by 2/7, and I just could really ignore the division by 7, and 6 divided by 2 is just 3, which is what we got here. So saying it in those ways kind of makes it confusing and doesn't seem clear why that would be true. But we can kind of see that it is true by this example, right? And most of the time when we're doing division, we're doing it with not common denominators, right? And so what we can think through is let's try to get a common denominator then if my denominators are not the same, right? So let's say I have two fractions, A over B and C over D, and I want to divide, but I don't have a common denominator, so B is not the same as D. Let's go ahead and just like we would with addition or subtraction, let's go ahead and get a common denominator. So A over B, I would multiply by D over D, right? So let's go ahead and zoom this in a little bit. Let's multiply by D over D. And C over D, we're going to multiply by B over B, right? Because I want to get the same denominator of B times D or D times B. Okay, and so this first number becomes D over A divided by D over B. And the second number is C over B over D over B, or C times B over D over B. Gosh, sorry, I'm saying that wrong. C times B over D times B. There we go. All right. And now if I use this previous rule, I have a common denominator, so then I can just divide the numerators. Oops. So that's D over A times C over B. So that's by that previous rule. I have in common denominator, so divide the numerators. So another way of rewriting this rule, or kind of rethinking this without getting a common denominator, is what we normally do when we divide. So if I think of the quotient A over B divided by C over D, just like I had before, one way I can do that is by multiplying by the reciprocal. So the reciprocal, let's see, the reciprocal of C over D is really just the multiplicative inverse. So it's D over C. So So that means if I divide by C over D, it's the same thing as multiplying by D over C. That's kind of what this whole statement here is saying, is that division by C over division is the same thing as multiplication by the reciprocal. So dividing by C over D is the same thing as multiplying by D over C. Great. So since we know a lot about multiplication, we just did a bunch of examples. This should be helpful. Okay. So let's look at some examples of division just to work out any kinks. I have a bunch of them written out here. So first and foremost, if I take 3 divided by a half, well, I know that's 3 times the reciprocal of a half, which is 2 over 1, or 3 times 2, which is just 6. Okay. Great. So one thing I'd like to point out with this example is that it's very common for students when they have just only worked with whole numbers to think of division as always making things smaller. And we can see with this example that if I take 3 and I divide by a half, I'm actually making things bigger, right? I started with 3, I divided by something, but now I get 6. And there's also something happening here where, yeah, I'm dividing by a half. That's the same thing as multiplying, right? The reciprocal. So really what I'm doing here when I divide by a half is I'm doubling. Okay, so there's a couple different things here, but one of the big concepts is just because I'm doing division doesn't mean that I'm making things smaller. Okay. Okay, great. And so we can do the same technique for this example. I have 21 over 40. I'm going to divide by 7 over 8. So that means I'm going to multiply by 8 over 7. And here would be a nice example of where it might be nice to, before multiplying these things out, to look at some common factors and see if we can simplify some stuff before combining numerators and denominators, if that makes sense. So for instance, I know that 8 is a factor of 40. 8 times 5 is 40, right? So, and 21 is really 3 times 7. So I'm going to write 21 as 3 times 7 and 40 as 5 times 8. And now, of course, I'm just multiplying numerators and denominators. So I'm going to leave this in the factored form for a minute here. It's, of course, not fully factored, but I have at least a list of common factors here. And I see that I am multiplying and dividing by 7. So 7 over 7, that's just 1. 8 over 8, that's also 1. So this is really 3/5. Oops. So, so here was a case where definitely I think looking at common factors makes this much simpler than if we were to just multiply straight across, multiply 8 times 40 and 7 times 21. Or I guess it was the opposite, sorry, right? 8 times 21 and 7 times 40. Okay, great. So another example, I guess I should say I encourage you as you're going through these things, these examples, to maybe pause the video and try the next example on your own before I go through, just to make sure you're understanding the concepts, or at least you can kind of come up with your own questions before you just watch it play out. So that would be one recommendation I have. You might also actually want to work through the whole notes and try all the examples first. It's up to you how confident you feel, and then kind of work them with me. So there's lots of options. Okay, so let's see. We're dividing by 6 over 11, so we're really multiplying by 11 over 6. Let's see, let's factor this a little bit just to see if things simplify, just because 11 over 21 is going to be a big number. So 21, we said that's 3 times 7. Let's see. I'm not too worried. This 40 and 11 don't have any common factors. So I might actually not even need to factor the 40. You can if you want to. I'll just leave it as 40 for now. If that felt weird to you and you want to factor it, even into its prime factorization, that's absolutely fine. But what I'm noticing is that there's nothing with the two numerators that are going to simplify that 40. But 6 we can write as 2 times 3. And 11 is prime, so I can't factor that any further. Okay, so I have 3 times 7 times 11 in the numerators, right? When I'm multiplying, I just multiply numerators, multiply denominators. It's not that exciting. And then the denominator is 40 times 2 times 3. And this allows me to cancel the 2 and the 3. So this is making things a little bit simpler. The numerator then is just 77, and the denominator is, I think, 80. Okay, great. Okay. All right. In our next example, here we're dividing these two mixed numbers. Last time when we were talking about multiplication with mixed numbers, we talked about two different ways to look at it. We can leave them as mixed numbers, or we can rewrite them as improper fractions. In the case of division, I would think rewriting them as improper fractions is really kind of the only way to get through here. And the reason is because I'm going to have to take a reciprocal. And the reciprocal is nice and intuitive for an improper fraction, but when I have a mixed number, like I do here with 6 and 3/4, taking the reciprocal of that is kind of hard in this form. So since we're going to have to take the reciprocal, let's just go ahead and do this as writing these guys as improper fractions. So I'm going to write 11 and 2/5 as an improper fraction. And so 11 is 55/5. So this should be 57/5. And it's divided by 6 times 4, that's 24. So 6 is 24/4 plus 3. So that's 27/4. And rewriting this division as multiplication, oops, sorry about that, 57/5, it becomes 57/5 times 4 over 27. Let's see. I don't immediately see that these things are going to simplify very nicely. Just kind of trying to think of, what I'm looking at here is seeing if there are any common factors between, say, 57 and 5 or 27. But I don't see any. Let's see. 27 is 3 cubed, and I don't think 57 is not divisible by 3. Or wait, no, it is. It is. Okay, never mind. Sorry about that. So 57, I think, right, because 7 plus 5, that's 12, which is divisible by 3. Yeah, so that's 3 times 19 is 57. And just leave this as 4. And this is 3 times 3 times 3, or 3 times 9, however you want to write it. Okay, and so my 3's do cancel. So 19 times 4, just multiplying my numerators, is 76. And 5 times 9 is 45. Great, so I can leave this as an improper fraction, or I can write it as a mixed number. And 45 goes into 76 one time. And the remainder is 31. So either way is a perfectly fine way to leave our answer. It's nice to, like I said, kind of get in the habit of writing it both ways, just so you're comfortable going back and forth with the improper fractions and the mixed numbers. Okay, number 5 is a very similar example to number 4. The only difference is that we have written division in this fraction form. So I think that there is, yeah, I think, oh yeah, your book refers to these as complex fractions, where you have a fraction divided by another fraction. And here, and this is where multiplying by the reciprocal is really the most kind of helpful idea. So what you'll want to do is think of this division as multiplying by the reciprocal. So again, there's a couple of different ways we can do it. We're going to want to do two different things. We're going to want to write these fractions as improper fractions, and we're going to want to multiply by the reciprocal. So let's go ahead and just write them as improper fractions first, because we know we'll need to do that. So here we have 1 and 4/7. So that should be 11/7 as an improper fraction. And we have 3 and 7/8. And let's see, 3 times 8 is 24, plus 7 is, so that should be 31/8. Okay, so this is what we call a complex fraction. And so dealing with complex fractions, or I guess either one of these really is kind of a complex fraction. Dealing with complex fractions is a really thing to kind of expose students to early, because expressions in this form, when it comes to algebra or pre-calculus or calculus, can really trip students up when they're not comfortable dealing with them at this elementary level, or yeah, and even in this exact level. So really what we're saying here is this notation is really the same as division, right? There's no difference. It's just a different notation. Okay, so we're taking 11/7, we're dividing by 31/8, and so what we're really doing is we're going to multiply by the reciprocal. And the reciprocal of 31/8 is 8/31 over 31. Okay, I don't think anything's going to cancel at all or simplify at all. 11 is prime, 8 is only divisible by 2, and 7 and 31 aren't divisible by 32. So in the numerator, I have 88, and then 31 times 7 in the denominator, which is 217. Great. Okay. Great. Okay, so one thing I wanted to mention, or actually a couple things I wanted to mention at the end here, is kind of as you're going through, paying attention to some of your intuition. We talked at the beginning of these examples about when I divide 3 by a half, I get a larger number. So I think it's kind of good to, as you're going through, kind of pay attention to whether I'm going to get a larger number or a smaller number, whether my number is going to be bigger than 1 or less than 1, and kind of what to expect from my outcome. So like looking at number 4, I'm like, I can look at this and I say to myself, I'm essentially dividing 11 by 6 or 12 by 7, something like that, right? So I expect that my number is going to be smaller, and since it's, something like 11 divided by 6, it's definitely going to be less than 2, right? Because 12 divided by 6 is 2, or somewhere around there, right? So as you're going through, the same estimation techniques that we talked about before apply when we're talking about fractions, right? It's good to be able to kind of estimate and calculate some of these things mentally, so that when you're going through and you just maybe make a silly typo or a silly mistake, punching something in your calculator or doing some mental arithmetic, you can kind of check yourself at the end and say, oh, when I look at number 5, would I expect a number? I have these two mixed numbers that I'm dividing. Do I expect this number to be bigger than 1 or less than 1? What size do I expect it to be? And I expect this number to be less than 1 because I'm taking something that's around 1, between 1 and 2, and I'm dividing it by something that's almost 4, right? Um, great. So this 88 over 217 seems like a reasonable estimation when it looks like I should be taking about 1 divided by 4 or something like that. And it's about a fourth, and so is 88 over 217. Great. So keeping that kind of, keeping in context the ideas of like mental math, estimation, um, as you're going through can be very helpful, especially since I think people don't tend to find fractions very intuitive. I think kind of checking yourself back and forth is a really good way to work with that. Okay, so at the end here, I had a couple other examples that you might want to try working on, and a couple of questions for that students might bring up. So yeah, that's most of what's in the notes here, and I will continue on with chapter 7.